Hello, Algebra 1. Here are your notes on how to divide rational expressions. But before we do that, let's do some prior knowledge. As indicated in this class, you know that a rational is nothing more than just a fraction. Rationals are fractions. Anything that can be written as a ratio, is a rational expression. So for prior knowledge, if I said I have 3/4, which is a fraction, and I want to divide it into half, our rule is to take that 3/4, and instead of actually cutting it into half, you end up multiplying by the reciprocal. The reciprocal, remember, the denominator ends up as the numerator, and the numerator ends up as the denominator. So they get switched. When you do that, then all you have to do is multiply across 3 times 2 and 4 times 1, and that gives us our 6/4. That can be reduced. 6 divided by 2 is 3, 4 divided by 2 is 2. 3/2 is the same thing as 1 1/2. So there goes my solution to 3/4 divided by 1/2. Well, we take this to a whole new level here in our algebra class. So let's go ahead and do example number 1 on how to divide rational expressions. Let's start off with 4 over x plus 2. I want to take that rational expression and I want to divide by 3 over x plus 2. Now notice I have a common denominator there, but we're not adding or subtracting. Instead, we are dividing. Just like we did in the prior knowledge section, instead of dividing, you want to be able to multiply by the reciprocal. So when I write the reciprocal, I'm going to go ahead and take that second fraction and write x plus 2 over 3. And instead of using a multiplication symbol, a division symbol, you're now going to use your multiplication symbol, your multiplication dot. Now you have the situation where you need to multiply your two numerators, you need to multiply your two denominators. And that's just like the problems we've been doing up until this point. So we're still going to get that practice in on how to multiply rationals here, even though we're dividing. That gives me 4 times x plus 2. Now, in class I said, be warned, it's very tempting to take these and then to do the distributive property. You don't want to do that when you're dealing with rational expressions, simply because if you do, you're going to have to factor things out anyways to get things to cancel out. And here I have my x plus 2's both canceling each other out. The solution here to this particular problem is 4/3, which is the same thing as a 1 1/3. So that's example number 1. Go ahead and take a moment to copy that down, please. Otherwise, the video will play on for example number 2. So here in example number 2, let's go ahead and do one that's just slightly more complicated. So we have our 3x as a numerator and our 2x minus 4 as our denominator. That needs to be divided by 6x squared over x minus 2. Same thing as before, you want to be able to take those rational expressions, instead of dividing, you're going to change it to multiplication. And instead of writing your dividend, I'm assuming your divisor, you're going to write its reciprocal. And that means whatever was on the bottom is now on the top, right here. And whatever was on the top now ends up on the bottom, 6x squared. Okay? So now we have a problem just like before. We're doing our multiplication. All we want to do is essentially factor these things. I'm going to go ahead and bring this down here to the bottom so there's more space. I can't factor 3x. I can't factor x minus 2. They're already fully factored. I can factor 2x minus 4 because a 2 can be taken out of both of those terms. And then I have a 6x squared. Now I have a situation where things can already start to cancel. My x minus 2's can cancel. I could cancel out an x from both top and bottom. In fact, 3 over 6 is 1/2. So that's 1/2. So let's go and see what's left. Looking at my numerator, all I have left is a 1. And in my denominator, all I have left is 2 times 2 times x, which is 4x. So there goes my final answer, 1 over 4x. Alright, we're going to go and do example number 3. If you need a second, go and copy that down. Otherwise, the video will play on. Alright, here goes example number 3. In example number 3, we are going to go ahead and divide now, but this time we're just going to divide by a polynomial. So if I have x squared minus 36, and that's divided by 2x squared, and I try to take that guy and divide by x minus 6. Okay, so we have the situation where there is no denominator. We know that any number can be written over 1, and when we do that, we now can take the reciprocal. So I'm going to go ahead and write that down here. X squared minus 36 over 2x squared. Instead of divide, it's now times 1 over x minus 6. Okay. The reason, by the way, that they used parentheses here is to know that it's not divided by x and then subtract 6. That'll mess with your order of operations. Okay, so down here I no longer need to write the parentheses, not until I start to do my multiplication. I could take x squared minus 36 and I can factor that, and again that's your difference of two squares, x plus 6 times x minus 6. Over here you have 2x squared on your denominator and you have x minus 6. So that's just your denominators times each other, your numerators times each other. Now you need to cancel stuff out. X minus 6, x minus 6. All I have left is an x plus 6 over a 2x squared. So here's your final answer, x plus 6 over 2x squared, and we're done. Alright class, that's it. Just 3 examples for tonight's homework assignment. We'll see you in class tomorrow.